Today we are doing the fundamental theorem of calculus, part 2. If f is continuous, if f is continuous at every point of a closed interval from A to B, and if f is any antiderivative of f on a closed interval from A to B, then the integral from A to B of f of x dx equals f of b minus f of a. If you didn't have that in front of you and you heard me say that, you'd be all confused. And I've actually read that off, and students are like, what? Many sorts. This says that any definite integral of any continuous function f can be calculated without taking limits, without calculating Riemann sums, and often without great effort, provided that an antiderivative can be found. In other words, the integral from A to B of a function is equal to the antiderivative at the upper bound minus the antiderivative at the lower bound. No Riemann sums, no rectangular area models, none of that stuff. If you can calculate the antiderivative, you can find the integral like that. Yes. Yeah. First day of the year I wear this shirt because I wait until this day to wear this shirt. And I used to have one that had, this one only has part 2. I used to have a shirt that had part 2 on one side and part 1 on the other side. But it wore out.
So where did you get this shirt?
I get them online. Cafe Press is where I get a lot of stuff, but there are a few other places I do. Cafe Press I like because most places where you get shirts and artwork and stuff like that, they pay the artist a one-time fee to be able to do them. Cafe Press pays royalties. So the artist gets the fee when it's originally purchased, and then they get royalties for everything that sells. Most sites don't do that. One of my son's friends actually gets royalties from some of her stuff that's sold on there. Not a lot, because she doesn't have a lot on there, but she's got royalties from it.
Which shirt would you recommend we wear for the test? Yeah. And I have a good question.
Can we do that?
Credit. I'm going to wear them on test. Like, because we don't show up with
We can all wear one.
There you go. Just get together as a group, decide what you want to have. I don't think that would necessarily be allowed.
Well, what if we
Okay. Quiet, please. Okay. AP rules dictates you can't have any information on the walls or anything like that. Technically speaking, you can take an AP test in any classroom, except this one. And you can take an AP test with any teacher proctoring, except for me.
So, Ram?
So, yeah. No, seriously, the way the rules are written, the teacher for your AP course you're taking it with cannot proctor your AP test. I can proctor any other AP test except for AP calculus. They actually have one of the counselors does it. The counseling department, or they get a sub or something like that too.
Oh, Lord.
Hey, she came in for my class. It's so cool.
I actually did.
So, yeah, no, that's just the way they do AP. And I understand they're very strict about the rules and what they have. And things with notes and stuff like that, this would not be allowed. And according to the rules, this would not be allowed. So, although one of the cooler shirts I've seen is it's called my multiplication test T-shirt. And you have your multiplication chart, only it's printed upside down, so you can look at it and look right side up. Okay, so yeah, fundamental theorem of calculus part 2. Once again, it's a simple equation. A very simple equation. Very powerful. This makes taking integrals really easy. If you can find any antiderivative, it will work. Any antiderivative. So one of the things you don't need to worry about when you're doing this is you don't have to worry about the plus c as part of your antiderivative, because you would have a plus c for this one and a minus c for this one, and the c's would cancel anyways. But because it's any antiderivative, it could be plus 0 and plus 0, so who cares about the constant? Okay, so it doesn't matter. Your constant does not matter on this one. Any antiderivative at b minus that antiderivative at a. Once again, if you can find an antiderivative, you can do this. Okay? And pretty much 90% of the integrals we do in here, from here until we get to chapter 8, are doable that way. And if you're asked to solve an integral on the AP test, if you don't have your calculator, they expect you to do it by hand. But they don't give a lot of integrals by hand to do. They give a few here and there. But they do give a few. They tend to apply them otherwise. If you're doing an integral, 90% of the time on the AP test, at least as far as the free response, you're expected to do it on your calculator. And they do give ones that you cannot find the antiderivatives of with your skill level. Okay, and an antiderivative will always exist. Finding it algebraically sometimes can be extremely difficult. Okay. So the notation when used evaluating integrals. This is important to see. Okay. So the integral from a to b of f of x dx is equal to f of x, the antiderivative x, from a to b. So it's a step-by-step process of solving it. So what you do is you have your function here, and this is your antiderivative of that function from a to b. That means you're evaluating at this point to that point. There are times when we'll see stuff here where it has something along the lines, and it just has the little number down there. That means you're evaluating at that point. That's what that symbology means. You're evaluating it. Lower bound to upper bound, that means I evaluated at b minus the antiderivative at a. Okay. I prefer the straight line. You will also see others, including your textbook, rather than using the straight line ones, you will see brackets. And they put a bracket around it, around the antiderivative, from a to b. Sometimes we'll just use the end bracket, the right end bracket, not the left end bracket, from a to b. Most of the time when they do this, it's because there's other stuff in your equation that you are not evaluating because it's not part of the integral and not part of the antiderivative. You may have an equation where the integral is strictly part of this bigger thing. Yeah, that happens. And we'll have examples of that as we move along through the material. Okay, questions so far? We haven't done anything yet except explain what it is. Once again, this makes life so much easier and doable. No Riemann sums, no limits, no rectangles, none of that stuff that you have to do if you can find the antiderivative. So let's do some examples. Okay, example number 1, solve the integral from 1 to 4 of 2x plus 3 dx. So my first step is to come up with an antiderivative. The antiderivative of 2x would be, not 2, 2's the derivative, x squared. Okay. Plus the antiderivative of 3 would be 3x, evaluated from 1 to 4. So you find your antiderivative. Okay. I want to evaluate it from 1 to 4. So that means I take 4 squared plus 3 times 4, subtract from that 1 squared plus 3 times 1. That's what I'm doing. Okay. 4 squared is 16, 3 times 4 is 12, 12 plus 16 is 28, minus 4 gives me 24. By the way, when we were doing stuff like this and when we had the problems that you guys were doing, the rectangles and stuff, and I said, okay, well, the exact area is this, I was doing this in my head. because it was easy. It's like the integral from the curve underneath x squared. Okay, I can do that one in my head very easily.
So like, I kind of see how it works, but like, what are we actually, like, what is this? We're with the antiderivative?
No, we use the antiderivative to evaluate the integral. This, okay, so if we go back and we say, all right, going back to where we were, you know, you've got your function and you've got the line, so you've got the line 2x plus 3, and I want to know between 1 and 4 what this area is. Well, that's what it is. It's 24. That's what we did. Now, this is not a complicated equation to be dealing with, but some of them can get pretty nasty in a hurry. And you've got some curve. This one, okay, you know what? I could calculate this by figuring out the trapezoid, the area of the trapezoid done by it. That wouldn't be that difficult to do. But if I've got a funky curve or funky equation, it does that. And if I have some of the equation above and some of the equation below, I don't have to worry about splitting it up into two integrals anymore. It automatically takes care of that. So we had a couple of them we were figuring out by solving the area. You go, ooh, it crosses the x-axis here. So we have this triangle underneath, and we have this triangle above the x-axis. Take the area above minus the area below. This does that automatically for you. All that stuff's all taken care of. Find the antiderivative, plug it in at the upper bound, plug in the upper bound, plug in the lower bound, subtract your answers. And it solves that for you. Okay. So example number 2. The integral from 0 to pi of sine x minus 2 cosine x dx. Okay, the antiderivative of the sine is negative cosine. I know it's a tough one. Negative cosine x. The antiderivative of cosine is positive sine. And I have the negative 2 there, so this would be minus 2 sine x from 0 to pi. Which means you need to have negative cosine of pi minus 2 sine pi minus negative cosine of 0 minus 2 sine of 0. And oh, this looks so hard, but if you know your unit circle, it's a walk in the park. Cosine of pi is negative 1. So this is negative 1, so that becomes plus 1. Sine of pi is 0. So I get 1 minus. Cosine of 0 is 1. So I get negative 1, so I get minus negative 1. Sine of 0 is 0. So I get 1 plus negative 1. I get 2. Like I said, it's even easier doing this than it is trying to type it in your calculator and have your calculator do it for you, because typing these things in your calculator can be a pain in the butt. So it's actually even easier than using your calculator in a lot of these. Like I said, this is it. This is one of the most useful things you will have from here on out, is being able to do this. And it all depends on antiderivatives. And part of the reason I hammer taking derivatives so hard is because the better you are doing derivatives, the easier antiderivatives are. It makes a difference. It really does. We may not be using derivatives, but if you can do derivatives, you can do antiderivatives. The easier one is, the easier the going the other direction is. Really makes a difference. Okay. Now, a few tips and tricks along the way. You may or may not do this, and let me do this. Hang on a second. Okay, we'll start over. Ooh, it magically changed colors. Okay, so a couple of tips on how to do some of these problems. So the first one, I have a constant times a function. Technically, this is the integral from 1 to e squared of 3 times 1 over r dr. R dr. What can I do with a constant? I can pull that constant out front. It's not that big a deal with 3. But if you have a complicated thing going on, pulling out that constant helps. Now, this also helps with doing the antiderivative. It makes the antiderivative more clear. What's the antiderivative of 1 over r? ln of r. It makes it easier to see. Seeing it here is a little difficult. Seeing it here is a piece of cake. Much easier anyways. Let's put it that way. So I get 3 times the antiderivative, which is the natural log of r, from 1 to e squared. So see what I'm doing? See what I'm doing? Making adjustments like this really does help with some of your work. Hey, take advantage of those rules. Simplify things for you. So this gives me 3 times the natural log of e squared minus the natural log of 1, which is 3 times the natural log of e squared is 2. Natural log of e is 1. But if I have the second power, so remember what do I do to the power? I bring it down on front. But if you have the natural log of e to some power, the natural log of e to some power is whatever that power is, so I get 2. Minus the natural log of 1 is 0. How do I get 1 by raising something to a power? What's that power going to be? It's going to be 0. Equals 6. There are a few things that you are expected to know by heart, a few values, your basic sines and cosines from the 4 corners, and pi over 4s and pi over 3s, and maybe pi over 6s. I haven't seen them too much. You're expected to know the natural log of 1 by heart, 0. You're expected to know the natural log of e, which is 1, and the natural log of e to some power is whatever that power is. You're expected to know those values for the AP exam and for me. Okay. Okay, next one. Looks nasty. What should we do first? Foil it out. You can simplify and work with things. Foil it out. Makes it easier to work with. Integral from -1 to 2 of q squared minus q minus 20 dq. Ooh, dq. So really, it helps. It simplifies your work. Doing it as it stands, originally, basically, I don't want to say impossible, but not something I want to attempt. There's no way I'm going to attempt doing this as it stands by hand. Foil it out, it's the only way to do this. From here, though, it's relatively easy. So the antiderivative of q squared, 1/3 q cubed. Okay. Minus the antiderivative of negative q would be -1/2 q squared, and then minus 20q from -1 to 2. And this part's a little nasty. Sorry, you're going to have to deal with fractions from time to time. And your calculators can't do fractions, but you need to know how to do them without your calculators. So that means I have 1/3 times 2 cubed minus 1/2 times 2 squared minus 20 times 2, all minus. I put -1 in there. That gives me -1/3 minus 1/2 plus 20. When I put in -1 in for q, it's easy enough to evaluate -1. 2 cubed is 8, so I have 8 thirds minus 2 plus 1/3 plus 1/2. Oh, I skipped one. So I get a minus 20 there, and then I have a minus 40 at that one, right? Yeah. Sorry, I skipped the minus 40. The minus 40 should be in here. My bad. 8 thirds plus 1/3 is 9 thirds, which is 3. So these two become 3. 3 minus 2 is 1. Negative 20, negative 40 is negative 60. Negative 60 minus 1 is, negative 60 plus 1 is negative 59. Negative 59 plus positive 1/2, negative 58 1/2. Sometimes they're really nasty and they won't cancel or anything. You have to get common denominators and all that crap. Just saying, sometimes you do.
So, why wouldn't the 1/2 second part, why wouldn't it be a positive?
Because it's positive 1 squared. Remember square first, then multiply times the number in front. Order of operations. Yeah, negative 58 1/2. Yeah, that pretty much covers everything. Yeah, that pretty much covers everything. Simple, easy lesson for the day.